All right, in this section, we're going to be looking at the green part of your rainbow review. So starting right off with number 1 here, when it says identify the rules for the following functions, it just means we want to add functions f and g together and see what we would get as our answer. So simply, we're just going to add together the like terms. So we would have 3x squared minus 2x plus 5 from function f. We're going to add that to negative 4x plus 2. So when we add those together, again, looking for like terms, we have 3x squared, there's no other x squareds, negative 2x and negative 4x combined to be negative 6x, and then we have 5 plus 2, which is 7. So we get 3x squared minus 6x plus 7. Now when we're subtracting, this is where it gets a little trickier, because subtraction, we would have 3x squared minus 2x plus 5, but we're not just going to subtract the first term, we're subtracting both terms. So I like to start by putting this in parentheses, and then we could distribute that negative through. So if I distribute that negative through, a negative times a negative would be a positive, and this would end up becoming a negative. So now we can combine like terms. So 3x squared, again, stays 3x squared. But I have negative 2x plus 4x this time, so this would be plus 2x. And 5 minus 2 would be 3. So when we subtract those, we get 3x squared plus 2x plus 3. All right, let's look at number 2. So here we want to find a rule and the domain for f divided by g. So the rule would just be we would have x squared minus 3x minus 18 divided by x plus 3. Now the first thing I want to do is I'm going to identify the domain. So the domain helps me look at, well, what we could technically, if we had this, we could put anything we want in for x, but since we have a fraction, we need to be careful with the denominator because we can never divide by 0. So for the domain, I'm going to say that x can't equal negative 3, because if x were negative 3 plus 3 would be 0, and you can't do that. So we can't have x being negative 3, but x could be anything else. Now let's see if this can be reduced at all, because when we're dealing with fractions, we want to see if they can be reduced. So looking at that numerator, I want to see, can that factor down at all? And so I'm going to look at the negative 18 and the negative 3. So what two numbers multiply together to be negative 18 that add together to be negative 3? Well, negative 6 and positive 3. Negative 6 times positive 3 would be negative 18, and negative 6 plus 3 would be negative 3. So I'm going to break that down to be x minus 6 times x plus 3. And if you notice, the x plus 3's cancel out. So the answer would just be x minus 6. All right, let's look at, and our domain can't be, or is x can't equal negative 3. All right, let's look at number 3. So we're going to evaluate each of these. So we're going to find f following g of 2 for this first one. So that means I'm going to start with g of 2. I'm going to do this in 2 steps. So I'm going to put 2 in a function g. Function g says to take negative 4 times my input. My input's going to be 2. So negative 4 times 2 is negative 8. So we just found that g of 2 is negative 8. So I'm going to put negative 8 in for function f. So when I do that, function f says to take 5 times my input, which is negative 8, and subtract 2. Well, 5 times negative 8 is negative 40, and negative 40 minus 2 is negative 42. So my final answer would be negative 42. All right, the next one. F following g of x. So now function g is negative 4x. So I'm going to put negative 4x into function f. Function f says to take 5 times my input and subtract 2. My input is at negative 4x. Notice what I did there. Sometimes when I'm working with students and they make a lot of mistakes, I recommend before putting things in, just put parentheses in with the little space in there for where your input's going to be. And then after you get everything written out, put in what your input should be. And the reason why I say that is because sometimes people forget the minus 2 on the end there. All right, but we got to simplify this. So 5 times negative 4x would be negative 20x minus 2. And negative 20x minus 2 cannot be simplified, so that would be your answer for 3b. All right, for 3c, we're going to take g following f of x. In other words, I'm going to put function f inside of function g, and function f is the 5x minus 2. So I'm going to put 5x minus 2 inside of function g. Function g says to take negative 4 times my input. And that's it. So my input is 5x minus 2. So I just want to simplify that. So I'm going to distribute the negative 4 through. So it'll be negative 20x plus 8, because negative 4 times negative 2 would be a positive 8. So that'd be my answer for 3C. All right, so on the back side of the green section, so for number 4, it says identify the inverse relation and is it a function? So the inverse, we're going to switch the x and y's around, but we're still going to call this x. We'll just call these the inverse of function f. So again, the x and y's, the domain and range switch. So these numbers that were in my range are now going to be in my domain. So 5, -1, 6, 3, 5, and 7. What was in my domain is now going to be in my range, and that would be the 4, 3, 9, 2, 8, and 1. All right, so to look to see if it's a function or not, we want to look at the domain. And I see that in the domain I have an input of 5 and I have another input of 5, but they have different outputs. Remember, to be a function for each input, you need to have only one output. So if I have 5 and I get 4 as my answer, and then I get 5 again, and get 8 as my answer, I have two different outputs there. So this is not a function. All right, so for number 5 is separate from number 4, by the way. So those do not go together. So number 5, it's saying if f of 6 equals 3, what's the value of the inverse of f of 3? Well, here's what you got to remember, the domain and range switch. So what this is saying is that when your input is 6, your answer is going to be 3. So and that's for function f. So that means the inverse is going to switch. So the input would be 3, the output would be 6. So when we put 3 into the inverse, our output, our answer, would just be 6. Okay, let's look at number 6 here. I don't know why that happened. Let's look at number 6. So number 6 says, if function f is 5x minus 4, what's the inverse of function f? So we're going to go through that process. The first thing we're going to do is remember that f of x is replacing our y. So this will be the same as y equals 5x minus 4. Now, to find the inverse, remember we switched the x and y around. So it'll be x equals 5y minus 4. So what was an x becomes a y. What was a y becomes an x. And remember, our goal now is to solve for y. So I would add 5 to both sides and get add 4, rather, to both sides to get x plus 4 equals 5y. And then divide both sides by 5. So I would get y equals x plus 4 divided by 5. But remember, we don't want to refer to this as y. This is now the inverse of function f. So that would be the inverse. Is the inverse a function? Yes, because every input would have its own unique output. It's also the graph of a linear equation. But now you don't have to worry about that. But yes, this would be a function. So your answer for that would be yes. All right, let's look at number 7. So number 7 says, similar problem. We're going to find the inverse of this function. So again, we want to start by looking at this as being y equals. So it's going to be y equals x squared plus 25. Now we want to change the y to an x and change the x to a y. And we're going to solve for y. So I'm going to subtract 25 from both sides. Now I'd have x minus 25 equals y squared. And then to solve for y, I would take the square root of both sides. So we would get y equals the square root of x minus 25. But remember, this is the inverse of function f, so we'd say identify it as such. So that would be your answer for the inverse. And it says identify an appropriate restriction of its domain. For when we're dealing with square roots, remember that has to be bigger than or equal to 0. So if I set that and set that x minus 25 has to be greater than or equal to 0, I would just solve that equation by adding 25 to both sides, and I would get the answer x has got to be greater than or equal to 25. Because 25 minus 25 would be 0, and the square root of 0 is 0. But if we use a number like 24, if we use a number smaller than 24, or smaller than 25, 24 minus 25 would be -1, and the square root of -1 would be I. And so we do not want to have a square root of a negative number, so we want to make sure that x is greater than or equal to 25. All right, number 8, we want to find the inverse of this function. So to find the inverse, I'm going to start again by changing this to be y equals. Then we're going to switch or change the x to a y and y to an x. So it'll be x equals cubed root of y plus 2. Now we're going to solve for y. Now that y is trapped underneath the cube root, so we're going to cube each side. So now we would have x cubed equals y plus 2. So to solve for y, we would subtract 2 from both sides and get x cubed minus 2. I'm going to just change this y now back to our function form. So I'm going to say it's the inverse of f of x equals x cubed minus 2. All right, lastly, number 9, it says use a composition to determine whether f and g are inverse functions. So to do that, what I'm going to do is I'm going to first put function g inside of function f, because we want to see if that equals x. So function g is 5x plus 15. And I'm going to put that in for function f, so it's going to be 1/5 my input minus 3. So my input's the 5x plus 15. So now if I distribute the 1/5 through, 1/5 of 5 is just 1, so we have 1x. And 1/5 of 15 is 3, so we'd have x plus 3 minus 3. Well, 3 minus 3 is 0, leaving us with x. So that one checks out, so that one works. So now I want to find g following f of x. So I'm going to put function f inside of function g. So function f is 1/5 x minus 3. So we're going to put that inside of function g. And function g says to take 5 times my input and add 15. My input is, again, 1/5 x minus 3. So watch what happens when I distribute the 5 through. 1/5 of 5 is 1, so we're left with 1x. And 5 times negative 3 would be negative 15. So we have x minus 15 plus 15. Well, that's all 0. So that also gives us x when we simplify it. So the fact that those checked out, that they both equal x when we simplify them, tells us that yes, they are inverses of each other. All right. So that is how you do the green section. So again, hopefully that answered all your questions. But if you still have some questions, please make sure you reach out to your math teacher, so then that way we can make sure that you're getting what you need to be ready for the test.